I've just added a coincidence rangefinder to MFCS, which is still very deep off into development. But don't worry, I'm going to show you how you can make your own, at any rate. The effect we're going to be making is this. So as you can see, things that are in focus are a certain range away, and things that are out of focus are not that range away. Very useful information, I know. Once again, I'm going to be splitting this off into sections. I'm not going to be writing this from scratch live, but I have the sort of logical progression of where you would go making this from scratch. And we come to the first step, which is getting over blank page syndrome. You should give yourself a pat on the back if you made it this far. Okay, we need to go somewhere from there. So we're dealing with rendering, so what do? Well, we run it on the client, first of all, so not shared. And this is just a little snippet you can do if you only want the chip to run on the owner being me in this case. All I want to do is draw a black rectangle in the top left of the screen that is, well, as big as a texture, so 1024 by 1024. In order to actually draw anything, we need to be in the draw HUD hook. And in order to use any sort of drawing hooks, we need to have a heads up display component enabled. And also adding a hook, you need to have an ID for what you want to add to the hook. So my unique ID is very unique. But anyway, this is what that looks like if I spawn the chip. There we go. Black square, 1024 by 1024. That starts at the top left corner of the screen. So we can render a black screen, or black square on the screen. Very nice. Let's look at the next step. Whole lot of crap. What this step is, oops, I just hit my microphone arm. That's good. So what this step is we're gonna be using renderView to render, well, another camera angle again. Now this perf ratio thing, do not worry about it. We do need to mess with render targets again, so we have this texture that I make that's named something. It doesn't really matter because I'm using the texture variable. Both of these functions really are one function together, but what I want to do is I want to render the view and then stop. I don't want it to keep rendering over and over. So I have two functions here. One is called start capture and one is called on capture. So all start capture does is adds the primary function on capture to the render scene hook. To call render view, you have to be in render scene, so that's why this is so important. And yeah, once again, you need a unique ID. There's my unique ID. But on capture, what does this thing do? Well, so we're going to be saving the information to a texture. So to do that, we need to use select render target, not set render target texture. They're two different things. So select render target sets a texture that you're going to be drawing to. I'm going to skip over this for now. We have render.renderView. This takes in a key value pair of basically, I guess, instructions. So you can see I have origin angles, aspect ratio, other stuff. Origin is going to be at my location, which is actually my feet. And the angles are going to be my eye angles. So I'm just feeding that into the renderView parameters, I guess you can say. So we do all that, we write to the texture, and we remove this thing from render scene because I only want to capture one frame and then stop every time I call start capture. There's a very particular reason I want to stop, like start and stop so much, but we'll come back to that in a second. So I'm still drawing my black square here in the drawing function. However, after that, to actually draw onto the texture, we do set render target texture. So this selects a render target to actually like draw with. We set the color to white because this is kind of like a tint to the texture. And then we just draw texture rect. And we draw it in the same position as the black square so you can't actually see the black square. So let's take a look at this thing over here. So renderView can be kind of performance heavy and you can end up tick quoting your chip very easily. So what I have here is if the chip is taking too long, it's not going to start the capture. So remember, when we do start capture, it goes into render scene and it goes out. So it gets one whole frame and stops. And so we're only using this sometimes, basically, when we can. But let's see what this does. There we go, we have renderView. And this kind of brings me on to the next step. You can see it's acting really weird. I don't really know why, but drawing your renderView texture, just using a texture kind of sucks. So we're gonna fix that, because since last time I've learned a little bit more about materials. And I do mean a little bit. So we have all the same things as before. We have this material, create, GMOD screen space. So everything is the same. However, rather than setting our texture and drawing with that, we are using render set material to our material, and we're telling that material to set a texture render target. And we have to do this base texture, $ base texture, give it the texture, and we just draw a textured rectangle again. Also notice we're not setting the color to remove the tint, because you have to do something else to change the tint on the material. But besides the point, let's see what this does. So yeah, this does kind of, this is what you want. You don't want like a flickering black texture when you try to draw things. It's that skeleton over there. Crazy. And from here things get kind of real. So remember, we're trying to make a coincidence rangefinder. So we come over, and let me just talk a bit about how this is supposed to work. So we want a position to my left and to my right, roughly aiming where I'm aiming, and we just want to render a view from the left and right. So to do this, I have two textures now, texture L, texture R, create two render targets. I still only have one material, and this material set float alpha 0.5, because I'm going to be joining the textures together. We want them to be at half opacity. And like I said, we want two holograms, so hologram.create. The position and angles really don't matter, as does the model. The model especially doesn't matter because I'm setting no draw to true, so it's not even going to try to draw them. Our capture functions have changed a little bit. So rather than capturing from my position with my angles, we want to use the hologram's position and angles. So you can see both of the functions have inputs for the entity we want to use, an ID for the hook. Go away. Gosh darn it. I have been informed that there is a wild Russian. Anyway, back to the grind set. So yes, we have three inputs, one for the entity we want to use, one for the ID of the hook, because we could have basically two of these running at once. So we need to have two unique IDs, but what exactly they are, the function doesn't know yet. And we have a texture, because remember, we have two textures. The function doesn't know which exact texture we're using yet. So yep, there we go. The start capture still uses the render scene hook. We use our unique ID, which is given to us, and we call on capture, or we give it on capture with the same parameters we have over here. Now you might be tempted to do this. This won't work because this is calling a function. We need to give it a function. So if you remember before, we didn't do this. This is calling a function. We need to give it the function. Alright, all good. So capture basically stays the same. We again have the inputs. So we're gonna select texture, our texture input from start capture. The origin is going to be the entity's position, the angles, the entity angles, that's about it. And we remove whatever ID from render scene. Alright, cool. Oh my gosh. So like I said, the holograms are going to be to our left and right. So left holo goes to the left, right holo goes to the right. So we start off by positioning the hologram at my position, it's at my feet. And to go left, we apply a displacement. To go right, we apply a displacement. Now, the displacement is this. So I can get my eye angles, which is the angles I'm looking at, and I can get a vector from that. So I want actually to the right of where I'm aiming. So owner, get eye angles, get right. And this is by how much? So times 20, arbitrary, I know. So left holo, set position, my position, minus right to go left. And right holo, set position, owner position, plus right to go right. Excellent. So now comes the matter of the hologram's angles. So let's see here. So we have this thing called focus position. And where I want the focus position to be is, again, add my position plus some displacement. So here I have owner get eye angles forward. So this is going to be a vector in the direction of where I'm aiming. And I have an offset of, or a length I suppose, of 1,000 units. Excellent. So that's what the focus position is. Now I need the hologram to aim at the focus position. So if you take the vector where you want to go, the focus position, minus where you are, the left hologram's position, get pose, we have basically another directional vector. Excellent. However, this takes angles, set angles, so we need to convert this to an angle, and we can use get angle ex and pass in just an upward vector so it can unroll itself. So my upward vector here is, just for convenience, 0, 0, 1. And you can see we do the exact same thing for the right hollow, however, we are subtracting the right hollow's position. So we get that directional vector, get angle ex up. Excellent. And of course we're calling start capture. Left hollow, we give it the ID of left and we're writing to the left texture. Excellent. Do the similar thing for the right hologram, only using a different ID and texture R. So here we go again, render set material, nothing's changed there. Render set texture render target. Again, base texture, texture L. We then draw a texture rectangle. And then to draw our right texture, well, we just set that texture render target, so base texture, texture R, and draw it. That was a lot of crap. Let's see what happens. And this is what we have. So, I just love the way the skybox flickers. So you can see, looks like the point, the corner of the roof is in focus because you can see lines converge and are in focus. They're not like blurry or anything. However, you can see that changes as I move around. So you can see like almost like a point coming in and out of focus. Let's see if I can get the tank in focus. Yeah, there we go. Yeah, this is what we want. Let's get Erickson in focus. There we go. There is a stage after this, however it's not as bad as you think because it's just some cleanup. So all it is I've added a few variables to control the properties of the rangefinder, so you can see FOV equals 60. So that this basically changes the zoom on the rangefinder, I guess you can say. The focus distance, so this is actually the range of the rangefinder. So remember, this was arbitrary before and at 1,000. Well, this is how you can adjust the range of your rangefinder. So I just set that to 1,000. The optic width. So the optic width, this is actually twice the distance, or half the distance between the rangefinder because it gets double, but whatever. Is the different distance between the two left and right holograms. You can change that up here now. Background color. So I don't have a perfect way of combining the two images over each other. You'd think half opacity would do it, but no, you would be wrong. So this actually bleeds through, so you can have like a tint on your rangefinder. Let me just show you. 60. Yeah, you can see the red tint comes on very strong. But you can also change your focus. This is how you adjust the range. Now, ideally, this would be being altered in like a mouse scrolled hook somewhere. This is close enough to finish on a like working rangefinder. Yeah, there we can see the focus distance is longer and my FOV is lower. And just from here you can see the effect of, I guess, the width. So if I set the width really small, so it was at 100, let's do like 5, so like 20 times smaller. You can see it's almost like everything is in focus, so it's a bit harder to tell if you have the correct range or not. This is why we like wider bases on things. It makes range finding easier, really brings out the difference, I guess. And that is it for the little rangefinder snippet, I guess. So that's kind of nice. Nice having its own video to focus on rather than trying to jam it somewhere else. And hopefully you find that useful. Maybe you make your own, stick it in your own heads-up display, or do something with it, just fool around. See how it works, that kind of thing. But that's gonna do it for this one. So, see you around.